saw it, so I knew that I needed to dissect it, and now I'm ready to make a video on it. It's called Skywork Math Data Scaling Laws for Mathematical Reasoning in Large Language Models. The story goes on. And it's put out by Skywork AI, Kunlun Inc. And then, so this is another research paper coming out of China once again. And then just highlighting it, I think that the reason why these research papers are coming out of China is because China is, in my opinion, specifically willing to and investigate these issues on a actual academic framework and approach. Whereas whenever I see these debates like around these subjects within the United States, in my opinion, it tends to be very like emotion driven and not academic driven. And so I just like I that's my reasoning for why these papers are coming out of China as opposed to like the United States or Europe or anywhere else. But so with that said, let's dive into what this paper is and what it says. And so this paper very specifically is with regards towards mathematics and the mathematics within AI models and LLM models very specifically. And then so it's been a known issue for a long time and for a while that AI, like mathematics very specifically, is a area where LLM models still struggle with as compared to humans across the board. The best models that we have right now, they can test right now around like with extreme fine tuning and all of that. You can get around like maybe a bachelor's to a master's in mathematics, like in a specific mathematical field. But that would be like about as high as we can currently go with the models so with regards towards math. And most models, it's pointed out a lot that they struggle with these concepts overall, and there's a lot of reasons for that. But so this paper does like delves into what appears to be the biggest reason within that, and then so like the biggest summary, like the biggest breakthrough within this paper, not to like kind of drag it out, is the fact that we're not giving the models enough mathematics data across the board, like period. Like, and so they do this test, and then so essentially what they do, and to prove this out, is they take a 7B model and they fine tune it on synthetic data first of all, synthetic, and then it's supervised fine tuning. So just like general fine tuning is just creating the data sets like prompt response pairs, and then just shooting that into the model, what anyone could do overall, basically overall. And then, but they create like a lot of it, and then they feed that to the model, and then within that, they're able to get it to score like. So they highlight that it scores and it outperforms an earlier version of GPT-4. Like so, there's like the current version of GPT-4 would outperform this 7B model, but again, this is a 7B model, right? And then so. And then they also show in the studies that there's not a 70B model currently on the market that outperforms this model. And then so if you know about scaling laws overall, everything this lines up within that. And then so what they're saying is that we're not giving these models enough data. And then if you just give them more math data, then they'll outperform. And then they didn't reach a limit of what more math data is. It's just more math data, period. And they give a like here in their highlighted takeaways, they give this, right. So that the potential for LLMs when it comes to math is far from exhausted, that they weren't able to exhaust it whatsoever, that it's just more data, and then counter that they use synthetic data overall is important to highlight. And then I think this is important to highlight as well, is that so counterintuitively, like selecting for what you would be like what you would say would be like the best data or the hardest problems to solve, etc. Counterintuitively brings down the scores in this model. Like you want, like when it comes to mathematics, like mathematics specifically. So you want, when it comes to mathematics specifically, as much data as virtually and humanly possible, like as much data as exists in the universe with regards towards mathematics, and you don't want to prune it out. Like you don't want like let's make it only the good data or only hard data or only let's scale it to like easy to hard problems, etc. Just give it like just raw, like the as much raw mathematical data that is as varied as possible is the key here. And like that's just what it is across the board, like as much of it as you can. And then other than that, there's like that's kind of the overall summation here. And then they also do mention like during the training that it's the other thing that had significant impact here was during the training, like preventing data leakage. So preventing data leakage during training had massive impact as well. And then also highlighting as well that they were able, and they showed that they were able to increase, and that there was benefit from increasing the tokenization number of tokenization when you're performing training. So like from 512 to, they went all the way up to 2048 tokens per cell. And were able to and they had significant improvement within that. So what they're able to show is that through long form, that this has significant improvement. One thing, and the last thing to highlight within this is just an overall highlight and summation, is what we're coming out with within this paper, is that the big thing is that what they showed is that this model does still lag behind, and what this method does still lag behind when it comes to like word problems very specifically. And then so that very specific set of word problems, and then that's important to highlight because the GSM-8K, which is like the major method for measuring mathematical performance within models, is heavily biased towards word problems. And then so they highlight that very specifically within this paper, and then pointed it out all throughout, that when it comes to that very specific segment of problems, of word problems specifically, it's the model's going to lag behind in performance as opposed to any other type of mathematical concept and problem. And then so significant because that's what the tests are biased towards overall. And then so just highlighting that. But so overall, the big takeaway, and the last thing to highlight within this paper overall, they give a lot of what their prompts are, and then how exactly they generated the data, and then what data that they used, and a lot around the data at the end of the paper. Like there's a lot of it's the paper itself is only like 9 pages, and then once we're getting into like these pages here, this is all just essentially like the support and analysis behind the paper very specifically. And then just like going into their methods and methodology. Really cool paper overall. And then you can see illustrations of their methods, and then they lay it all out, like they're all of their framework. And then pretty cool. I'll leave a link to the description to this paper overall. But the bottom line is that like there's, I think the biggest real world takeaway from this is that there's no, like, you can't overtrain your model on math. Like if you want your model to improve its mathematical reasoning, fine tune it on more math, like as much math as possible, and you're not going to like harm the model overall by doing that. And you're not gonna give it too much data, like you're not gonna have it overfit as long as you're giving it a broad amount of data, right? Like that's the broad and raw and as much of it as possible. And those are the kind of the 3 things, and then just stick within that and you're good. And this is again very specific to mathematics, and highlighting that this is very specific to math overall, and why I'm making this paper, making this video overall on this paper is because this does buck trends significantly when it comes towards these things. Like, and so only apply what is in this video and what I've been talking about very specifically within this towards mathematics when it comes to these models overall. So thank you very much, and I look forward to seeing you in future lectures and future videos.